Hey guys, this is Ben, again bringing you another video on how to build a IPSEC VPN connection. Today we're going to be building this connection between a Cisco ASA and the VPC endpoints. Now the reason for this tutorial, it seems that the Cisco ASA is probably by far one of the most popular devices among AWS users out there. And so hopefully this kind of helps you out. We're going to be talking about some do's and don'ts, some gotcha points with the AWS VPN service, and so hopefully this kind of simplifies the process for you. But before we get started, let's just kind of go over this diagram and what we're trying to do. By the way, I apologize in advance for my drawing here. It's probably not the best, but you get the idea. All right, so we're dealing with a VPC with a CIDR range of 172.16.0.0/16, and then a LAN network behind the ASA that's 192.168.0.0/16. And we're going to build this VPN connection that consists of two tunnels. Okay, the first tunnel is actually up and running, and then the second tunnel will be passive. In other words, it's going to be completely down. In the event that the first tunnel goes down, the second one will take over. And so then what we have to do at this point is create the VPN connection in the AWS console, which we'll get to here in a moment. We need to make a VPC route change or modification so that traffic can be routed over the tunnel to the LAN behind the ASA. All right, so that's kind of the diagram. Let's get started. All right, so I'm looking at my AWS console here. First of all, just disregard all the deleted customer gateways and anything you see deleted. I was working on a project earlier today, so I don't want that to confuse you. But just to show you how this process works, let's go through this first. With regards to AWS, the AWS VPN service, it consists of three components. A VPN consists of three components. You have the customer gateway, which is the customer side of the connection, in this case the ASA, and the virtual private gateway, which is the AWS side of the connection, and then finally the VPN connection itself, which is bundling all that information together to create the parameters in a single config file that you can use to set up your ASA. And let me demonstrate how this works. So the first thing we want to do is create our customer gateway, and let's go ahead and do that. Let's give it a name we'll recognize. So Cisco ASA. The ASA, it currently doesn't have support for BGP over IPSEC, which is dynamic routing here, or at least with regards to the AWS VPN endpoints. It does support BGP over IPSEC, but just not with the AWS service. So for now, just leave it on static routing. For the IP address, you want to put the public peer IP of the ASA. So in my case, it's going to be 52.8.42.235. We're going to go ahead and create that. All right, so that's available now. We're going to the second component, the virtual private gateway. Again, I was working with some projects earlier, so disregard that. We're going to create a new virtual private gateway. We'll just give it that name. Once you provision the virtual private gateway, you'll see it in detached state. You want to attach it to your VPC. So in this case, it's going to be the VPC that we talked about earlier, this one right here. So I'm going to attach it to that VPC. All right, it's attaching, and you may have to refresh your browser every so often to see it finally attached. Once you've created your customer gateway, the virtual private gateway, then you can go on to create the actual VPN connection. Again, this bundles all that information together. Let's give it a name here. All right, this is the VGW I just created. We want to select an existing CGW since we've created that one. And again, it only says it supports static routing. For the static IP prefixes, you want to specify the LAN network behind your ASA that's going to be communicating. So in this case, it's going to be the 192.168.0.0/16 network. That's what we're going to specify here. And that's it. Let's go ahead and create it. Now this can take a couple minutes, so I'll be right back as soon as it's done creating. Alright, so it's done creating here. But before we go on to configure our Cisco ASA, let me we're going to make a quick modification to the VPC route table, kind of what we were talking about earlier. Obviously, in order for traffic to work to and from the on-premise network behind the ASA, we need to create a route in the VPC route table so it knows how to reach. So the VPC knows how to reach the 192.168 network, right? So we're about to modify the VPC route table, and it's going to look something like this after we're done. So let's go and do that. We're going to go over here to route tables. I got a lot of route tables, a lot of different VPCs. Disregard all of those except for the relevant one here. We're going to modify the route table for the 172 VPC. And you'll notice at the moment I only got one route, and that's my local route within the VPC itself. I'm going to go to the route propagation tab, and it says, and you should see the same for your VGW, it currently is not being propagated. The VGW that we created earlier, we're going to edit that and hit the propagation checkbox, save it. And what this does is all the prefixes that we have listed under the VPN connection, in this case the 192 network, will be propagated through the VGW to our VPC route table automatically. This is the best way to update your VPC route table with VPN networks. Okay. Right now it's not showing up, but eventually the 192 network will show up here, and we'll look at that later. But in the meantime, let's go back to our VPN connections. And we're going to select our VPN and hit the download configuration button. We're going to select the Cisco vendor, ASA, and 8.2 plus. And they do have the 9 point, and above now, but I'm just going to go, actually I have the 9 point. Sorry. So, so go ahead and download that now. And you'll notice that if you open this under regular Notepad, it may not format the config file in a readable format. So you may want to use something like Windows WordPad to open this text file. I'm going to open it now. And okay, here's the number one rule. If there's one thing you should take away from this video, it's this. Do exactly as the config file instructs you to do. Don't try to go off on your own and configure this VPN some other way or using different VPN parameters. You want to stay as close to this config file as possible when setting up your VPN. If you do that, you could be up in a matter of 5 minutes as opposed to banging your head against the wall for the next 2 hours. So try to stick to this config file as much as possible. Okay? All right, so the next thing I like to do, that makes it easier on me, is to actually pull the configuration portion. A lot of this is just description, right? And talking about what each of these parameters are, how it's used. And that's great. It's good to read through that. I would recommend reading through this so you know exactly what you're doing. But other than that, what I like to do is pull the actual configuration out of this file and put it into Notepad. And that way I can just slightly modify it so that it meets my configuration or can be used by my ASA. In some cases, you may already have some of these objects with the names that this config file recommends. It's okay to use different object names or names of ACLs. If you want to rename those, that's fine. But again, you don't want to change any of the actual parameters encryption-wise or hashing or lifetime values, anything like that. You want to leave exactly as they recommend. So let's go ahead and go through this. And the first thing we're going to modify here is the ISA camp policy. This is for phase 1. So what I like to do here, let me just open a new notepad. I'm going to paste that in right there. Obviously it's saying, hey, whatever the name of your outside interface is, you're going to rename this. So the name of my outside interface is outside. All right. Next, we're going to create the tunnel group. Again, this is part of phase 1, just establishing that secure channel. And the pre-share key, it's all there. ISA camp keep alive. This has to do with dead pair detection. Dead pair detection is used in an active passive failover. So just real briefly, you have an active passive tunnel. Dead pair detection will send DPD messages between these peers, these public peers, and as long as your Cisco ASA is getting a response back for that DPD message, it'll keep this primary tunnel up, right? If that DPD message fails, then it's going to tear down this tunnel and the second tunnel will take over. All right, so that's what we're configuring right now with the ISA camp keep alive threshold 10, retry 3, and that's the first tunnel group. This is the second tunnel group of the passive tunnel in this case. You might find that some of this stuff is redundant. That's fine. Okay. The next portion that we're going to cover here is the access list. Now, my ASA does not have any access list in place, so I don't really need to add these explicit access lists to allow the public peers to talk to each other. I'm going to leave this part out of my configuration, but if you are using access lists on your ASA, you may need to include those. Now, this is probably one of the biggest areas that I see people mess up in. They have multiple LAN networks behind their ASA, and so what they naturally try to do is create a access rule for each of their LANs, source LANs, to reach the destination VPC CIDR. The problem is that this access list is used by the crypto map of the Cisco ASA. It's using policy-based routing. And so for each of those source networks that you specify, it's creating what's referred to as a security association, right? Well, AWS only allows one security association with their VPN endpoints. That's because they used route-based routing on their end. They don't use policy-based routing, and so they send all traffic destined with the proxy ID of 000, which can cause a conflict with your Cisco ASA. I know that that's really wordy, and don't worry about all that. The main thing to keep in mind is that you need to summarize all of your source networks into an any statement, a source any, and then of course the VPC CIDR destination. You can lock down traffic access using the built-in VPN filter, which we'll get into later on. But this particular rule that it needs to be a single rule, okay, for this to work, and the source needs to be any. Okay, that's very, very important. So let's go ahead and pull this out. Add it to our notepad. And I'm just going to modify this because my VPC CIDR is this. Right? Okay, that's great. And moving on down, we're going to create a transform set. This is just the encryption parameters to be used. And finally, the crypto map. The crypto map is, of course, what brings all these parameters together. and encrypts the traffic. This, so real briefly, you can name this crypto map anything you want. Well, as long as you don't already have a crypto map in place on your ASA. If you do, you just want to call it whatever name you have in place and give it a sequence number. If you already have crypto maps set up on your ASA, you probably know how to do this already. So I won't tell you again. This first line specifies the ACL to use for policy-based routing, which is the ACL we were talking about earlier that needs to have a single rule. And this is going to create a single security association. Okay, so everything looks good there. Moving along. We need to apply the crypto map to the outside interface. And, whoops. Oh, there we go. I'm just taking these brackets off, and we're going to apply the crypto map to the outside interface. This next section in your config file is somewhat optional. And the important thing to note here are that these are global commands. If you have a lot of production VPNs running off your Cisco ASA right now, you may want to investigate this a little bit further before implementing these changes. But I don't foresee it being a problem even if you do have existing VPNs. You could probably put these in place and not see any negative impact. If in fact you could probably see some improvement in some ways. Just real briefly, so the crypto IPSEC DF bit clear is basically just saying, you know, don't clearing the don't fragment bit so that traffic can fragment if it needs to. I'm going to apply this to the outside interface. So if you're seeing performance issues, right, like a low throughput over your VPN, you may need these in place, okay? And replay window size. Oops, I got a couple monitors here. Crypto IPsec fragmentation before encryption. This is just instructing those packets to be fragmented before encryption. Kind of just like it sounds. And we're setting the TCP MSS to 1387. This is assuming that your physical MTU on your interface is 1500, and this number right here allows for the IP headers, IPsec headers, I should say. Again, all these are performance related configurations. They are global, so just be careful with them. Finally, we're going to, not finally, but we're going to enable the SLA monitor. The function here on the ASA is just to generate some interesting traffic over the tunnel, continuous ping, and this is going to keep the tunnel up and stable. Okay, so for the SLA monitor address, this can be the gateway of your VPC. So in my case, it's 172.16.0.1, and we're going to apply this to the outside interface. Okay. We need to make sure that we allow ICMP through our firewall. Okay. All right, so I was kind of talking about the built-in VPN filter. Obviously, it may not be practical for some of you to allow any source network over the VPN tunnel, right? This is where you can restrict the traffic. We're going to create an access list called Amazon filter, and this is basically locking down those networks. So 172.16.0.0, then the mask, starting with the VPC CIDR. And then we want to allow the VPC network to communicate with our local network while restricting all other networks behind your ASA. So that's what we're going to do here. Okay. You just take out that exclamation mark. That way it doesn't use it as a comment here. And pretty much just copy all of those, all the rest of these lines here. This is going to apply this filter. So again, all traffic is restricted over that tunnel except for traffic destined for your local network that you want to communicate, right? Okay. And finally, if you're using NAT, if you're NATing internal to external, you'll want to create a NAT exemption for all traffic going over the tunnel. Here we're just creating an object network of any and a destination. But you can see that this is all pretty much laid out for you, right? You don't have to do a whole lot of thinking. It's just modifying these commands to fit your own configuration and then applying them. You only need this NAT exemption if you're using NAT, right? If you suspect that you're using NAT, it's fine to just go ahead and apply it to be safe. It's not going to hurt anything else. This will only affect traffic going over your tunnel, okay? So that's pretty much it. Like, we've modified everything we need to do here, all our configuration. It's just a matter of pasting this into our Cisco at this point. So let's go ahead and do that. I have my Cisco terminal open here. I'm going to conf T and pretty much just Control A, Control C to copy all that text, then right click to paste it, and bam, it's done. Alright, so how do we know the tunnel's up? We just need to check it. There's a few commands we can run to do this. First of all, just exit out of global config mode there. And we're going to do a show crypto ISA ASA. This command is going to check to make sure that phase 1 is established. And if you see this message right here, you're looking good. You want to see role as initiator because you are the initiator of this connection in an active state, right? So phase 1 is up. Let's check phase 2. And the fact that you're seeing any messages here is a good thing. This indicates that, especially the SPI, inbound and outbound, this indicates that phase 2 is working properly and that your tunnel is now up. And we can just double check that by checking our VPN. If you look under tunnel details, you'll see that one tunnel is up. That's what you want to see. The second tunnel will be down because, again, the second tunnel is acting as a passive tunnel in this case. And then finally, what we want to do is from a device behind the ASA, we want to ping over the tunnel to verify that we can, ping this destination EC2. And so I have a device ready to do that here. Ping 172.16.0.132. And look at that, we have a successful reply. So that's good. And normally what you would want to do in this case is also jump on the EC2 as well and then ping in the opposite direction just to make sure that, traffic can be initiated in both directions if that's what you're wanting to do in your traffic flow. So, okay, other than that, I think that's about it. I hope this tutorial has helped you. And if you have any questions, feel free to leave a comment under the YouTube comment section, and I'll be glad to answer those for you. All right, have a great day.